So if you're watching this video, then you are getting ready to do the Soxhlet extraction, maybe quiz, or maybe you've already done the lab and you just need a refresher on what to do with the calculations. And if that's so, then that means there were some peanuts available for you, and no one ate them all. I have a tendency to eat the peanuts. Kim buys the raw peanuts, and she gets mad at me because every time the raw peanuts come into the lab, she says that I'm going to get worms because I'm eating raw peanuts. Maybe there is something to that, but they're still good, right? They might not have too much of a flavor, but they're still good. So the Soxhlet extraction is going to lead you through the process of taking a bowling flask that sits down here at the bottom, and then on top of this thing, you're going to have a Soxhlet extractor that basically recirculates the solvent, and then on top of that, you're going to have a reflux condenser that has water in and water out that condenses everything down for you. Down here in the center of the Soxhlet extractor, that's where your peanuts are going to be. So there's two different types of calculations that you need to do here. Notice in the other videos I kept talking about weights, and weights are also going to be important when it concerns the latter part of the laboratory experiment. So you also need the weight of the bowling flask that you will be using in the lab. So the weight of the bowling flask is going to be very important. It needs to be the weight of the flask empty with nothing in it at all. Okay? And the reason that we do that is because after the Soxhlet extraction, what you will have is a bowling flask that will have liquid in it. And that liquid will be your solvent, and it will be your oil. And we want the weight of the oil that we have extracted from those peanuts. That's what we need to basically get to in order to do the percent calculation. So what we do in this step is that we're going to have to heat the bowling flask up. And when we heat the bowling flask up, well, it drives off all of the solvent. All of the solvent will go away, and what I'm left over with now is just my peanut oil only. Oil only after the heat. I want to take this process very slow, and the reason is because I don't want to burn or char my peanut oil. That's very important, okay? We want the integrity to stay. So after I accomplish this, I'm then going to go and I'm going to reweigh the bowling flask that I weighed in the beginning, but this time it's going to be the bowling flask and the oil, okay? I can then take these two numbers and subtract them. And when I do that, that will give me the weight of the oil that is located in that bowling flask. This is what we call the direct calculation, because I'm directly calculating the weight of the oil that has been collected in that bowling flask at the bottom of the Soxhlet extractor. Try saying that to your friends. You might say pretty smart. So that number is the number that should be very close to the Merck value when you look up your peanut and your peanut oil composition, right? So the way that we do that is if I take the weight of my oil and the weight of the peanuts, and I divide those two, multiply by 100, then I will get the percent of oil that is in my nut sample that I started with from the very beginning. That number should be very close to the Merck value. That's what we call the direct percentage calculation. So that's one of the calculations that you're going to have to do, right? Again, we call it direct because we're directly measuring the oil that's in the flask. All right, now there is another type of calculation that you need to do. So here I've drawn a thimble, right? And I'm going to take the thimble out of the Soxhlet extractor once my process is completely done. And I'm going to allow this thimble to dry. And the reason is because that thimble will be soaked in solvent, and I want that solvent to be evaporated and I want it gone. So inside of this thimble, I'm going to have peanuts. But these peanuts now do not have any oil at all. All of the oil, hopefully, has been removed from them. Take a look at them. They'll look like little pieces of chalk when you get done. It's kind of weird and strange looking. Well, here's the next calculation that I can do. Okay? If I take the weight of the thimble and the cotton and the oil before the extraction, and if I take the weight of the thimble, cotton, and oil after the extraction, and I subtract those values, then that will give me the weight that was lost. And I'm going to assume that the weight that was lost was due to the oil that was located in the peanuts. This is what we call the indirect method. And we call it indirect because we're not really measuring the actual weight of the oil that was collected. We're measuring the weight of the peanuts before and the peanuts after. And the difference in those weights is regarded as the weight lost, which we're going to assume was all oil. That's why we call that an indirect measurement. Well, I do the same thing. I take the weight of the oil that I'm getting from here, and I divide that by the weight of the peanuts that I started with, and I multiply by a 100, and that will give me the percentage of oil. The difference is that this is a direct percentage, and this one is a indirect percentage. But you know, it's two sides of the same coin, meaning that this oil percentage and my indirect oil percentage, they should be pretty close. And again, if they're not identical, it's okay, because we're assuming that all of the weight that was lost was due to the oil in the indirect method. And that's not necessarily the case every single time. Okay? So that's how you will calculate the direct percentage and the indirect percentage in the laboratory. So, weight of the oil from the flask minus the weight of just the flask empty, that is the direct version. And then you look at your peanuts. What was the peanut weight before? What was the peanut weight after? That difference is what you lost. So that difference is regarded as the oil weight, and you do the same type of calculation there. Now, one more thing that I want to kind of tell you about before you start the lab is that we're going to want you to do this 3 times. And the reason that we want you to do it 3 times is because we want you to calculate the average direct percent. We want you to calculate the average indirect percent. We want you to calculate the standard deviation of each one of these, and we want you to report that on an Excel spreadsheet. Okay? So you have to generate an Excel spreadsheet for this lab. You're doing multiple sample runs with multiple Soxhlets, and we want you to calculate averages and standard deviations. If you've never used Excel to calculate a standard deviation, you need to let us know, and we will walk you through that part. It's pretty easy. If you've never used Excel at all, you need to come and let us know, and we will show you the basics of Excel so that way you can get this data generated and printed out and put in your lab book so you can grade it, so I can grade it, and you can get a grade for it. So that's the story at the very end of the lab. That also means that if you have an Excel spreadsheet, do not forget to print out a formula sheet. You're doing Excel calculations, and that means a formula sheet should come along with that, and that's very important. Okay? So that's it with the Soxhlet lab. So pretty simple. You can actually do another lab while this one's running. You just need to set it up, turn on the heat, make sure the rollover times are appropriate, and then once that's going, then you can walk off and leave it. Not a problem at all. Go do something else and then come back to it a day or two later and then finish this up. And I think that you'll be okay. So kill 2 birds with 1 stone. I prefer you not to kill any birds at all. But if you're going to, make sure that you don't do too much work and make sure that you have a pleasant experience while you do it.